opens up for you. All right, so then we're going to go to Learn, and we're going to change this to Circuits. We're going to go to Projects and Show All Arduino. And we're going to scroll down just a little bit to do the ultrasonic one, which is actually right here, so just right there. So click on that one. And when this opens up, sometimes it takes a few moments to load everything. We're going to see that this sample that they start with actually has 4 different builds on it. I'm not quite sure why it has all 4. It should only have 2 in my opinion. So I'm going to go ahead and delete some of these. So there they are. It looks like there's only 2, but when you go into the code, again. Okay, what's going on here? Yep, so there's the code. You can see there's 4 Arduino boards here. And basically what it is there's 2 of these and 2 of these on top of each other. But the difference between this one and this one is the ultrasonic sensor. This is the ultrasonic sensor. This one has 4 pins. This is generally what we have in the classroom and what I see when I go to purchase these. But there are 3 ones out there, and so this lesson is actually written for the 3rd one. I'm sorry, the 3-pin ultrasonic, so we're just going to stick with that so it doesn't get confusing between the 3 and the 4. But this is generally what I buy and have in the classroom. So just to show you, if I drag this down a little bit, you can see there's another one underneath of it. So anyway, I'm going to delete all of this by clicking on it and clicking delete, either on the keyboard or right up there in the top left. Do the same thing here. Delete. It's going to say, are you sure? Because you're getting rid of code and everything. So yes. And it goes away. And we're going to get rid of these as well. And again, there's 2 of these. So if I drag this down, you're going to be able to see that there's 2. So again, I'm going to hit delete and delete. And then we can hold the shift button down and select all of these at one time if we would like, or you can do one at a time, up to you. I clicked all of them by holding the shift key down and then delete, and they're gone. So the same thing's happening here. If I was to drag this over, there, and I drag this over, oh, of course, to here, yeah. These wires are the ones, yeah. And then delete this. So I'm going to delete this one and say OK. And I'm going to delete this side. And again, holding down the shift key, selecting all these. And I think this computer program is going to run a lot quicker now that we don't have 4 of these in here for some reason. Okay, go through the introduction. We didn't do the PR motion sensor, but that is something you could do if you wanted to learn about those type of sensors instead of this ultrasonic sensor, which tells us distance. So it just goes through and down here, it tells you to click on this thing here when you start the simulation. You're going to have this object that you can bring closer and farther away. It's going to tell you what it thinks. It is 26 inches or 67.7 centimeters away. And you can zoom out a little bit so you can drag it a little bit farther away. But the ultrasonic sensor, you got to click on the ultrasonic sensor to see this. It does have a limit, and eventually it doesn't detect it. So once it gets in here, it gives you what it's detecting as a distance. And it goes basically straight in front, a little bit to the right, and a little bit to the left. And that's what the ultrasonic sensor does. Sends out these sound things. So read through this. Learn a little bit about ultrasonic sensors, and then click next. So the first thing we're going to do is build. So what we want to do is build this right alongside the sample, so we can use the sample as a sample. So the first thing I'm going to look for is the Arduino, and there it is. I'll bring it out. And a breadboard. I'll bring that out. And you can follow directions right along. It says drag out the Arduino and breadboard. Connect the 5 volts and grounds to the positive and ground side of the rails or the breadboard, and change the wire color. So I'm going to zoom in here a little bit and basically do what they have here. So 5 volts, down, around, and there. I'm going to line these up so they're nice and straight. Actually, I'm going to leave it out here. Let me bring this way, just a little bit. There we go. Click on the wire, get those blue lines to show up. So they nice straight wires, and then change the color. I push 2, and that changes it to red. But you can also come up here and select what color you want. Then I'm going to do the ground. Same thing, clicking, clicking, and I'm going to just come straight up into that. Again, making sure that the wires are perpendicular and nice and neat, just because that's the way I like it. And I'm going to push 1. That's going to change it to black. But again, you can come up here and change your color. All right, next, we're going to use 220 ohm resistors to each of the left leg, or the cathode, of the LEDs. So we're going to bring in 3 LEDs and connect all the all this over here, basically. So scrolling up, bringing this in to here. Doesn't matter, any one of these would work. I'm going to choose that one. Bring another one in. Oops. There. And I'm going to bring another one in and bring it there. And then we need a resistor. And I'm going to put it on the straight side, not the little bent side over here is the anode. This is the cathode. And I'm going to change this to 220 ohms. And you can see now that my banding matches up. I can highlight that one and Control C, Control Paste, I think. Yep, there it goes. Control V, Control C, Control V. Copy and paste. I can paste it again. And that way I don't have to change the values because they're already 220. And then we're going to run the wires to number 2, number 3, and number 4. So on this side, connected to this anode, we're going to run a wire down here to 2. And yeah, let's make it yellow. So we can come up here, choose yellow. We're going to do the same thing here and make it come into 3. And let's make it orange. So again, you can push numbers. Number 3 is orange. And lastly, we're going to come in here. And if you wanted to straighten up these wires, you could. And we'll make that red. So remember that 2 is red. Or we can come up here and change it. So there we go. The LEDs are all wired up. So that was step 3, 4, and 5. Step 6, continue to the next step. All right, so this is adding the proximity sensor, also known as the ultrasonic rangefinder sensor. So yeah, there is a difference between 3 and 4 pins. Read through those, learn a little bit about that. But I think the directions here are going to basically tell us how to do it on the 3-pin one. So that's the one I'm going to go find, and I think I either have to do all or type in ultrasonic. Yep, there it is. And I'm going to use the 3 one. So I'm going to click on this one, and I'm going to stick it somewhere over here. It doesn't have to be in the exact same rows. Those are in 4, 5, and 6. I'm going to put it in 6, 7, and 8. Just make sure that the wires that you are connecting here are going to the same pin. Doesn't have to necessarily be in the same breadboard rows. Okay, so it says wire up the sensor so that the 5-volt pin connects to the 5-volt rail, voltage rail. So we're just going to do, here's 5 volts. I'm going to connect here to here. Perfect. And we're going to do the ground rail. So here to here, changing the color to black. And then the signal one is going to go to the Arduino pin 7. So we're going to go from here down to here, to here, to there. And I'm going to wire that. I'm going to make that green. So there we go. I think that was 5. Okay. And so that's basically what they had. We can just check it. Make sure we did everything right. And if you had the 4-pin, yeah, if you had the 4-pin, you'd have some different things to read through here. So if you chose the 4-pin, that is the one that we generally see, that's what you have to do. All right, so now we're going to code with the blocks. So this is a little tricky. I'm going to slide mine over so I can see a little bit of theirs. And then start my code. So this code that comes with my Arduino, you can click on theirs, and it shows you their code. You click on ours, and it shows us our code. This is what comes built in. We don't need that, so we're going to throw that away. I'm going to drag this over so I can have a little bit more room to see things. And then read through this. So we already did this. Click the code button, open the code editor. We're going to put in some gray notation blocks. It isn't really required. These are what we call comments, and they're calling them notations. And then we're going to create a variable. So let's go ahead and do that. Go to notations, bring in a single line comment. And you can see for them, they commented, zoom in here, set threshold distance to activate LEDs. All right, so we go back to ours. Actually, you know what I'm going to do? Make it simpler and easier for us. I'm just going to select this by clicking on it, Control C, go to mine, Control V, and paste that in. Okay. Then we have to go to variables. We have to create a variable, just like it says over here, and create a new variable called distance threshold. So we're going to type in distance threshold. Like that. Make sure we spell it right, because we have to spell it the same all the time, or the computer doesn't know what we have done. And it says use the set block to set it to 350. So here's the set block. Go and drag that in, change the 0 to 350. To store the sensor value, create a variable named cm. So again, we're going to create another variable. We're going to call this cm for centimeters. Hit OK. Drag out a set block and adjust the drop down to our new variable cm. So yeah, it's already done for us since we just typed that in. It says to bring out the ultrasonic distance sensor block and place it in the set block. So we're going to go to, let's say, input category, and we're going to read this one. Read the ultrasonic sensor and put that here. So let's see if I can drag this over, see as much as we can. And we attach this, as it's going to say in the next set, to number 7. So if you remember, this one right here is going to the 7. So we need to choose that option here so that it knows. We're using the 3-pin, so you can see we can keep our echo and trigger pin the same, and our units are going to be centimeters. Just looking back at the sample code, each time we have to zoom in a little bit to see it. They had another comment, didn't really talk right here. We can put that in there if we wanted to. So I'm going to go ahead and select that, Control C, go back to my code, go back to notations, and drop in that block right there. select, Control V, and paste that in, just to help us understand what this is doing. This line is measuring the ping time from this side to that side, or vice versa, and how long it takes this to bounce off an object will tell us how far it is away in centimeters. Okay, now optionally, and I think this is a good idea because this is a STEM class, so we want to learn a little bit about math, science, technology, and engineering math. So we got the technology covered and engineering covered. But the science here is that for inches here, the difference is there is 2.54 centimeters in every inch. So when we take the centimeters and we divide that by 2.54, if it was 2.54, it'd be 1 inch. The same number over itself is 1. There's a little bit of math for you. So that's what we're going to do next. Again, if you want to just look at the sample and see what they did, here they have the set the inches to centimeters divided by 2.54. I got another comment in there, so we can read the directions. But we can also look at the sample. So again, clicking on this, copying, Control C, going back to mine, clicking in Control Paste. We have to go to variables, as it says here, create a new variable. We have to create a variable. We'll call it inches, just inches, I think. Good. And now we're going to set that variable. We're changing the drop down. And then we're going to bring in a math block where we divide by 2.54. Let's just take a look at the sample. Yeah, that's what they did. Centimeter variable, divide by 2.54. So we're going to go back to ours. Get the green, the drop down math block. This one here, I guess. Put that in there. Now we can put our variable centimeters in here and divide by 2.54. All right. So it looks a little bit different. Looks like the drop down is now the actual divide by symbol instead of, oh yeah, you could pick either one, it looks like. So that's the one they have in their sample. All right, so now it says add some serial monitoring blocks to print out the sensor distance in centimeters and inches. So if you remember when we clicked on this, on the sample code, and we were starting the simulation, we could see numbers here. And so that's nice for Tinkercad. That's not how it really works in real life, but it is nice for this application. So click on the control category and drag out an if-then block and then navigate. So let's just check the sample, see if we've gotten everything. Oh yeah, so this, we need to do these first. Print, print, print. So let's zoom into these. I'll give you very good, give you very detailed directions of how to do this. So we're going to print to the serial monitor, which is down here. When we get this running, we'll show you that. The centimeters without a new line. Then we're going to print the units, actual text, cm, comma, without a new line. And then on the same, so basically on the same line, print the inches variable, which we just set here by taking the centimeters, dividing by 2.54, and then put the units on it as well, so that they make sense to a user. So let's go back to ours and do that. So print serial monitor, here it is. Hello world is in there. We're going to change that to our variable centimeters. So there we go. And then we're going to do the same thing, and maybe you want to do all 4 at one time. Here, here, and here. This one is just going to be the units, centimeters, comma, space. And then this one is going to be our variable of inches. And the units for it, inches. And just check out the sample, see if we did it right. So again, zooming in every time. Wish it would hold it, but it doesn't. So I think the one difference, no, looks good. I think we got it. All right, don't mess up the sample. So now we're doing if-then statements. So you can see kind of what we're going to be building. It also talks about it over here. click the control category. So we're going to go back to ours. Well, we can follow these directions. Bring this up a little bit. Control category right here. Bring in if-then statement. It says if-then block right here, if-then block. Then navigate to the math. So then we're going to go to math and drag out the block into the if block. So we're going to compare. I think it's this one. But again, let's just go check the sample by clicking on this Arduino and see if we did it right. Yeah, it looks like a greater than. Okay, I think that's what it's going to tell us right here. All right, so let's go back to ours and continue reading. So here in the variable category, grab the centimeters variable. So then click on variables, centimeters, plop that in there. Basically what we're doing is we're setting up the lights to turn on and off, the LEDs to turn on and off. So, and the distance threshold variable, and drag them into the block. This one. And basically reads if centimeters is greater than the distance threshold. So we got to change this to greater than, because right now this is less than. Change that to greater than. All right. So if the ultrasonic sensor is giving us a centimeters unit that is greater than our 350, then what lights do we want to turn on? And so we want to add 3 digital input blocks that set all of them to being off. Basically low is off. So we're going to do 2, 3, and 4 to, oh, not this one, this one. Set pin 2 to low. And again, I like to duplicate. I right click, duplicate, right click, and change that to 3. Change that to 4. And so there we go. 2, 3, and 4 to low. Duplicate this if statement 4 times. So that's nice. Speeds up the coding. Duplicate all 7 and put it here. And we're going to change this threshold comparative block. So it says 4 times. So again, I guess I can duplicate. That's, oops, well, let's snap in. Oh, yeah. Going back and forth just to see what's going on. Oh, I got something underneath here. What's going on? I can't drag this out of the way to see what's happening. A little glitch here, I think. Let's try this again. Grab it. No, not let me grab. Maybe refresh. Maybe my internet. My internet sometimes is going in and out. All right, good. So that's all there. Again, I drag this over so I can just barely see their Arduino, so I can click on it when I want, and then bring out my code. Make this as big as I can so that I have room here to work and see. Zoom in. Okay. Try this again. Okay. So somehow that got in there and we don't want that there. There we go. And that's 2 times. So let's duplicate it again. What if we clicked here if it duplicated it? No. Just click here, duplicate all 7, put that there. So I think at the end we end up with 5 different ones. So one more time. First one plus duplicating 4 times. Oops. Go back. This is where we were. Just we were down all the way down here. So yeah, it says 4 times. So it should give us 5 over here. Let's see. 1, 2, 3, 4, and 5. And now we're going to change what it says. So this was if it was greater than the distance threshold. The next line, the first statement is the distance is farther than the threshold, so no LEDs are lit. That's what I just said. When the distance is closer than or equal to the distance threshold and greater than the distance threshold minus 100. So basically 350 minus 100 would be 200. So somewhere between 350 and 250, we're going to light up 2 LEDs, or light up only pin 2 LED, just the 1 LED. Okay, this says temperature. This is not correct. But anyway, let's set up this one. So we're going to need some math blocks here. And we're going to need this and this. So we're going to bring this one in here. And we're going to say when this is less than the distance threshold, so less than 350, and again, we can duplicate this, and it is greater than the distance threshold subtract, so we have to throw that in there, distance threshold, how did they do that? I thought that's how I would do it. Subtract. Huh. Interesting. No. Yeah, there we go. So I got to put that in there first, it looks like. And then throw that in here. There we go. 100. So 350, that's the variable we set up here. Can't see it anymore. Minus 100 gets us 250. So anywhere it's less than 350 and it's greater than 250, then run this. And that's where we just turn on the number 2. Okay? So now we can just basically, I think it's best to kind of take this one, and we're going to throw this away. And we're going to duplicate this and put it here. Okay, so now we want this to be basically this value. So I'm going to just take this and put it here. And so now we've got, if it's less than, if this ultrasonic sensor's distance is less than 250, 350 minus 100 is 250, and greater than, so I feel like we could throw this away, oops, all of this away, and just duplicate this one again. Oops, that's not what I wanted. Go away. Oh, having that problem again. All right, so make sure we click on the right spot. Yeah, something's glitching again. Like it won't let go. Let me see if I zoom in or zoom out. It'll let go of it. Nope. Huh. It looks like I gotta refresh my page again. Can't get this thing to go away. So, refresh. So because these, we want these LEDs to show us different distances that we're running into. This code is a little bit more complicated than maybe we're used to. So I'm going to scoot this over, carry this over, throw this away. Okay. Zoom in. That is, so where it's supposed to be. We got to figure that out. All right, so again, I'm going to duplicate this, throw that in there. All right, so now what I need this to say, if you read it instructions, scrolling down, back here. All right, so minus 100, light up the second one. When the supposed to be distance threshold is between what we were talking about, 250, and basically 350 minus 250, so that is 100. So between 250 and 100. So I'm going to change this to 250, so that we're talking if it's less than 350 minus 100 is 250, and greater than, I'm going to change that, 350 minus 250, which is greater than 100. So somewhere between 250 and 100. Then we're going to light up two LEDs. So we're going to light up that one and that one. Okay. And again, I'm going to throw this away. Oh, maybe not. Let me see what the next statement is. And so on to account for all the desired states. That's what it says. It doesn't give us instructions. It wants you to think on your own. We can look at the sample, but basically here we're at 100. So let's go to 100 to 0, I guess. Let's see what the sample did. So this is where we are, 250 to 350. So they went to 0. This is also at 0. I don't really know what the difference is between these two. But we'll do it. Let's see how it behaves. All right, so again, I'm going to throw this away. Duplicate this. I want to make sure I'm on the and. Duplicate that. Put it in here. So again, this is going to be 250. Basically get it to 100. And 350, which basically gets it to 0. So if it's in between 100 and 0, then we want to light up all the lights. And then this one just says if it is less than 0 or equal to 0, I guess if it's equal to 0 is really what that one is, because this is already taking account to 0. I think that's what we need to do, is just make it equal to 0. So I'm going to take this block, zoom in so I can see what I'm looking at. And scroll down. Don't need this. I'm just going to say equal to 0. Make it simple. Let's see what they did. Yeah, they got distance threshold minus 350, which 350 minus 350 is 0. And they said less than or equal to. I don't know how it would be less than 0. Maybe that's important. Then maybe we should do it the way they did it. And then it says wait down here. It says wait 0.1 seconds. But we'll read the directions just to see what it says. So anyway, we're going to take this, basically all of this right here. I'm going to go back to my code, get rid of this line, duplicate this one, throw it in here, and change this to less than or equal to. The distance threshold is less than or equal to the distance threshold, which is the number 350 right there, minus 350, so that's 0. Then make all these high. Again, I'm not 100% sure what the difference between this code and this code is. All three lights are on. This has an equal sign. This doesn't. It's greater than, but it's still 0. So it's greater than 0. This is actually less than or equal to 0. I don't know. And then we need to wait. So let's go to next. So we could look at the text it's saying, basically going up here, instead of just saying blocks, look at blocks and text and kind of see what the blocks created over here. But if you look at the sample, they have a weight here. So let's just go ahead and add that. It doesn't really tell us in the directions to do this, but we know in the sample, it's there. So wait 0.1 seconds. So let's go to its, scroll down, control, wait, 0.1 seconds. And that's it. So that should work. Let's go ahead and check it out. Make this go a little bit closer this way. I'm going to open up the serial monitor so we can see what's going on there. And read through this, guys, and just make sure you understand what the code would be if you were typing it and what it means. And then if you wanted to build it yourself at home, you'd buy these parts and build it at home. All right, so let's go ahead and start simulation. So what happens is right now you can see it's printing out values. If we can make this a little bit bigger. Because right now the object is 44.7 inches or 113.4 centimeters. So 2 lights are on. If we come a little closer, remember we had to be under 100, 3 lights come on. And then really 3 lights stay on if you get closer than that. So I'm not quite sure what these last two things are, but sometimes when you build this stuff, you would have to play with it a little bit. Oh, get rid of that. To see what the values are, what you actually want the values to be, adjust the code to respond to the real world situation that the sensor is picking up. So you might stick your hand in front of this and measure your hand to this ultrasonic sensor just to get a feel of what it's actually happening, sensing when your hand is there, so that then you could adjust the code so that the robot or the object, the ultrasonic sensor, would behave the way you want it to behave. So you can see right here, that's happening there, but it's also happening here. So if we go above 350, which we can't really, it doesn't register anything. I feel like the values are a little off. Maybe start at 300 with 1 light or no lights. And we could say 329 is our max, 330 is our max. So maybe we need to adjust our number. But for this lesson, we're done. It works. We get 1 light, we get closer, 2 lights, we get closer under 100, 3 lights. There it is. And again, if you get closer, it goes 3 lights too. So the only one that's really not being ever called upon is when we're greater than 350, because that's not an option. So you could go over here, change this to 300, because we know we can get greater than 300. But then that changes these. Oops, I don't want to do that. That changes these values as well. So we need to play with that a little bit to get it to work just the way we want it to. So what do we want? We want centimeters is less than 300 and is greater than 200. All right, that works. Is greater or less than 200, but greater than basically 50. We do 2 lights, and then if it's less than 50, of course, I'd say let's go to like 280. So basically, you're getting pretty close now. And then if you wanted to make it a little bit different, you can make this 300, so it actually gets to 0, but really less than 10. Like once you got 290, you better, 300 minus 290 is 10. You better change your wheels or something, or change your, get farther away before you crash into it. So, you could put a buzzer here or some type of other command other than 3 lights. But for this case, that's what we've done. So now let's go play with it Let's see if we can get no lights if we're greater than 300. All right, we've got one light because we're between basically 200 and 300. So yeah, if we go greater than 300, yeah, that light went off. Yep, there it is, fully off. And then we get less than 300, one light comes on. I think it was less than 200. Two lights should come on, perfect. And less than 50, is that what it was? So comments there would be nice. There we go, 3 lights come on, less than 50. And then it talks about optional stuff is adding a buzzer and stuff. You can try that code in here that the buzzer goes off when you get, maybe within 10 or something like that on this last one. That's all I have for you. Hope you can get that done today.